Well, we did the product rule, and if we were to refresh that, that would say that if we're multiplying common bases, that'll give a product, that's why the name's there, we add exponents. So by default, the quotient rule is when we divide common bases, we wouldn't add exponents. We would probably, using a little bit of common sense, subtract our exponents. And there, by definition, is what you've got. So you can write this another way too. I'll write it out. I'll say x to the a divided by x to the b. And again, the a and b could be any numbers. It doesn't matter. And it's still going to be, hey, we're going common bases division, subtract our two exponents, a minus b. Okay, so either or. I'm just going to put an or here. Just like that. All right, so let's look at an example, and you'll see how simple this is. Again, this all comes from this simple idea of the expanding. So maybe I'll do that in the first example. I'll show you 3 to the 5 divided by 3, well, let's say 3 cubed. So if I were to expand this, now I'm going to put it right beside here so we can see what we're looking at. So up top here, that exponent 5 is telling me I got to multiply 3 by itself 5 times. So 3, 5 times. Now that's all divided by, again in the bottom, and now I've got a 3 multiplied by itself 3 times. 3 times 3 times 3. So now we're basically looking at division of numbers. So again, if I start here, I can say, what's 3 divided by 3? Well, it's 1, so it cancels out, right? So I'll put a 1 there, it doesn't matter. 3 divided by 3, well, that cancels out, I'm left with a 1. 3 divided by 3, that cancels out, I'm left with a 1. All right now, so what's left over when there's nothing left? I got 1 times 1 times 1 times 3 times 3. Oh, so 3 squared times 1. Oh, or I could have just said 3 to the 5 minus 3. 5 minus 3 gives me 3 to the 2. And if we wanted to evaluate that, 3 squared is 9. Okay, so it comes from just the expanding rule, just sort of like the product rule did. We just expanded to see how it worked, but then we realized, oh, we can just take a shortcut. So I'm going to quickly throw down another example right here, and I'll use variables this time. I'm going to say p to the 11 divided by p to the 8. Well, I don't know what the base p is, but I know they're the same, and I'm dividing. They both have exponents. I can subtract my exponents. 11 take away 8 is 3, so I say base p. You never touch your base. You never, ever touch it, to the power of 3. A lot of people, especially with the product rule for some reason, they'll actually multiply the bases. You never, ever, ever touch the base when you're using exponent rules, okay? You touch the base, or you evaluate the base when I ask you to evaluate. Otherwise, when you're just using the exponent rules, just do the exponent rules. Let's do one more before I let this one drop. Let's go with something like that we won't evaluate because it'll be too big. Let's go with 4 to the power of 15, and let's divide that by 4 to the power of 6. Now, 4 to the power of 15 is monstrous big. Heck, 4 to the power of 6 is too big in my world. But I do know that I'm dividing common bases. I'm not going to touch those. The common base is a 4. Again, a lot of people screw up. A common mistake is they'll put the number 1 because 4 divided by 4 is 1. Do not do that. You don't touch the base. But you do subtract your exponents in this case. 15 take away 6 is 9. And I'm done. Now, I would never expect you to evaluate that, so don't even try. So there's the quotient rule. That's about as hard as it gets. I'm going to leave you with that one.